Welcome everyone to this week's IPLD weekly meeting. It's 10th of February 2020. As every week, we go over the stuff that we've done last week and plan to do next week, and then discuss any open items we might have, or also introduce everyone who's new to the call who wants to introduce himself. Let's perhaps start with this. So I see a new face. Will, do you want to quickly introduce yourself? If you don't, that's also fine. So,
just listening to see what's going on in IPLD world.
All right, cool. On my list is, I start with myself. I sadly haven't done that much IPLD related work last week, but this week I definitely will have time to work again on the Rust side of things, and mostly I concentrate on the multi-format stuff because there's several pull requests open and forks, and again, getting them together and having a solid base for basing IPLD on. That's all I have. Next one on my list is Michael.
Sorry, I needed to unmute. So basically last week, I got to the comp generation side of this big data set project. And so it immediately just crashed Lambda. When we investigated it, it was using a lot of scratch disk space and a lot of memory. So hit it up with Rod. Rod figured out, well, first Rod dropped into Rust, and that got rid of some of the memory usage, I think. But still using a lot of scratch disk and memory, and then Volker got it down from there, and I think Rod has gotten it down even farther. So now I think we're finally like near the point where it'll run in Lambda on Rust, this forked version will, without crashing, hopefully. But this also exposed a problem where we've been generating car files that are just a little bit over a gig, because we thought that the way that Filecoin's sector padding worked was that you assembled all the pieces into a sector and then you did the padding. But the padding actually happens at each piece. So each piece has to be a size that's a factor of 2 of the sector. And so that meant that a file slightly over 1 gig would pad to 2 gigs, which is like all of the data almost that we've been producing for this. So I have to go back and rewrite the slicer and the allocator, and then regenerate a small data set, make sure that it all works, maybe run it through comp if that's working by then, and then also write a very large running migration script to move all of the old data to new data that will slice and allocate into car files that are less than 1 gig. So that's my last week and this week. Also finished up reviews last week, so all of you that have reviews, I've got one-on-ones with today to go over them, and that's about it. I don't know who's next.
Next is Tim.
All right. So last week was productive. I went through all the constraints I was given for selector syntax and came up with this very esoteric syntax that may work. I don't know. I mean, if it's the constraints. So I wrote up a PR describing it, and I'm going right now writing a parser for it to verify it's not horribly ambiguous. The biggest issue I see is we may have problems in the future with like old versions of the syntax and new versions of the parser and vice versa. It's not a fully self-documenting syntax. It needs some context. So we'll have to decide if that's a good idea or not. But yeah, just this week, I'm looking forward to feedback on that and iterating. And that's pretty much it.
The context piece of that, does that apply to the fully parsed form as well, or just the syntax that before parsing?
Well, because like in a structured data format like JSON, you got quotes, you can have arbitrary keys. Whereas with this, with the keywords, you only know where the keywords start and stop because you have a fixed dictionary of keywords that are allowed. There's no spaces to differentiate.
Right.
So technically, it's a very compact encoding, but I'm not sure it's flexible enough for migrations. So I'll have to see about that.
I mean, maybe Eric can think of a case that I can't, but like in all the cases that are in my head, I would not be worried about having to have a version specific syntax parser. as long as the parsed form is fine and doesn't require that context, then we can always hit the parsed form and know exactly which version it is if it needs a version. But I may be missing a use case that I hadn't thought of yet.
Right. I mean, yeah, the IPLD data structure is the source of truth. It's just the one I'm most concerned about is if I have a new version of the syntax and I'm using an old version of the parser, it probably won't know what to do with it. But if we don't care about supporting that, we're fine.
Yeah, I think we're okay, at least for a while. If we find a case where that's not true, then we'll worry about it when it comes in.
Cool. Next one is Eric.
For what it's worth on the selector DSL stuff, I think as long as you don't go too crazy with the bear words, I'm not super worried about the migration either. Your last couple of comments about that I saw chronologically in email were whitespace has some semantics. And I think that's fine as long as you define it as a whitespace token collapses arbitrary amounts of whitespace. Like that's a pretty common thing. Anyway, 2 cents. So I just sat down and did lots of code this week, which was nice. I'm about on par with where I hoped to be from last week, which is I'm re-implementing the whole basic IPLD node packages for untyped stuff to conform to the new interfaces for performance purposes. And I pretty much finished that up. There's a new implementation of lists and new implementations of all the other scalars that all fit the new interfaces. I'll have a bunch of new tests. And so next week, it's just carry that stuff into the core. And that's going to be fun. So right now, all of this stuff is written in a branch called research, and it is in some other package separate from the main ones in order to control the scope explosion while I work on it. And the next thing up is to merge it into the main folder on the master branch and deal with the explosion of everything else. So I'm going to hope that I can port all of the codecs, all of the traversal logic, and all of the selectors to the new interfaces. And I'm going to claim that I can do that in a week. We'll see. It's a little bit of an aggressive bet, but like maybe. These interface changes will also probably generate some work for anything downstream that's using it. And I'm mostly thinking of, I think like, there's a DAG protobuf interface repo out there that I think Hannah is the primary author on, and that's going to need some updates, but hopefully pretty easy ones. And anything like this should have versions pinned by hash, so it's not going to like completely break down the doors. Should be able to absorb that leisure. As I carry all of these updates through for the codecs and traversals and selectors in this core stuff, I'm actually going to take the current CodeGen packages in the repo and temporarily abandon them because I don't think the utility of keeping them migrated live is going to be worth anything. I'm just going to like write a bunch of those as lessons learned and do a reboot after the interface changes lands. And I think that's just going to be easier. And there are some lessons learned, so it's like purifying Passover as well. And I'm having a lot of fun doing test corpuses now. So something that I've learned from the last time I tried to do serialization libraries is the matrix between probing every edge case in serialization and all of these recursive structure assemblies, and also dealing with what may be typed or untyped flexible data at the same time. The number of cases that you have to test for is just really enormous. So I'm starting to put some extra effort into making sure all of the test specs shape up nicely this time. And part of that's just naming them, unfortunately, like making sure I know which things I have cases covering. So if this goes ideally, I want to have one set of programmatic test specs that say like, this behavior should confirm correct operation of a map, so long as that definition of a map has string keys and integer values and these particular keys. Which is funny because if you have an untyped map, that's a bunch of constraints you don't need. But if you're using this on a piece of typed information that is a struct that happens to act like a map, then suddenly all that extra entropy matters. So I'm starting to write test specs with that in mind. It's fun. That's about it. It's my week.
Thank you. Next on my list is Rod.
Okay. So I start the week off doing JavaScript CBOR. Very close to publishing a basic decoder and encoder minus tag support for now. I just want to get it published so I can do the work in the open. So that was the bar I was trying to get to, and just need to finish floats to get that done. I'm keen at about exploring the vertical integration potential between parser all the way up to schemas. So instead of just treating, traditionally in JavaScript, particularly Node, we would be very strict with our module boundaries. But I think if we change the way we think about codecs in IPLD and JavaScript, there's a lot of interesting potential for connecting that vertical. Anyway, that's something I've been toying a lot of with in my head, and while I'm building this thing about how, say you do some code gen with schemas, you could really build in intimate knowledge about how these things get encoded if you build codecs that can work in a similar fashion. So, you know, it's really easy if you say, okay, I'm doing this schema and I only care about CBOR. Great, you could do some really cool vertical integration. If you want to be more flexible, then you'd have to have codecs that play nicely together. And a lot of this comes from Go, where Eric's already got a lot of this playing nicely. I think there's still a lot of potential in Go to connect all the way from the codecs all the way up, but there's still a lot of vertical stuff going on where things can swap in and out, and you have efficiency gains by not treating the layering as super strict, or just bleeding them into each other a little bit more in a sensible fashion, without, you know, while being a good modular citizen. Anyway, that's why I started the week and then got distracted with other things because this Filecoin stuff came up. So the other two things I was working on was quickly some car format fixes for JavaScript. It turns out that Michael wanted to just throw data at the car file generator, and my APIs were assuming that you were going to be a nice await citizen and calmly await for the blocks to be written, but so I had to change that and make it actually write things sequentially and assume that things could come in without waiting. So that seems to be working now. I'm still keen, Michael, to spend a bit of time testing different car files that you produce with this thing to make sure that they are actually doing what they're supposed to do. But we'll get there. And then the other thing was the com file generation thing, which Michael mentioned. So the two things that we discovered when digging into the actually what we were doing was going from doing this in Go and then using the Go libraries, which did some of the work, and then crossed over the FFI boundary into the proofs in Rust. And we're basically now, we've moved like 3 steps closer to almost re-implementing the proof stuff, which has, you know, which we need to think carefully about how much of this we really want to do. But it turns out there's the 2 areas of that it's using disk are running the padded version. It writes it to disk. The only reason it does that is because the padding algorithm has this little seek in it that just hops back a byte or 2. So when you give this padding algorithm a reader with a big, huge, you know, that can read sequentially like a stream of bytes, then it wants to be able to move forward and then go back a little bit and then forward and then back a little bit and then forward. And so because it needs to do that seek, you can't just give it a pure stream unless it had the appropriate amount of buffering. So what the proofs does is write it to disk and then feed it from that disk, that temporary file, so that it can do that back and forth thing. So Volker wrote an in-memory version of it, which just writes it to memory and then it can move back and forth from memory. and then we found it was still using double the amount of the piece size in disk. It turns out the Merkle tree algorithm in there that it's using to generate the CompP, which is just, CompP is just the Merkle proof of the thing, and so of the piece, and it does it divides it into 32 bytes, and then hashes them, and then makes a Merkle tree with arity of 2 all the way up to the final piece. And the Merkle tree algorithm that it's using uses a disk cache to cache the pieces as the hashes as it's working up this tree, and that. So the code that does the disk caching is can actually take the library that's doing the Merkle tree stuff can either take a disk cache or a memory cache, but in the Filecoin proofs, it's hardwired in as a disk cache. So now I've got a link there just to a re-implementation of it that just does a bit of copy pasta from the proofs code and replaces it with, for the first one is the padding thing that Volker implemented, and the second one is replacing the Merkle tree call with something that'll call it with a memory cache. So we can now swap out disk for memory, but it still uses 3 times the size of the piece, rounded up base to approximately. So yeah, for a 1 gig piece, it's using nearly 3 gigs of memory. And then on top of that, if we turn it into a Lambda thing, then we add more memory overhead because of whatever else we have to add to make it play nicely with Lambda. And then on top of that, we've got the decision point about are we comfortable using this thing, which is now using less of the actual proofs code and it's using a custom re-implementation, or do we want to do other routes? But that's,
I mean, we're gonna have to watch that repo really, really closely. I mean, just for Steven's benefit, since he came in a bit late, the problem that we ran into is that like we have some interesting constraints running these in Lambda because we have to do so many concurrently. And the main constraint is that we don't really have any scratch disk space to use, but we can get up to like 3 gigs of memory. And we can get the car files down to just below a gig. So as long as we can not use disk and use less than 3 gigs of memory per car file CompP generation, we're fine. But anything over that, then we run into a lot of problems. And so that's why we've been working on this.
Question real quick. Do you guys have access to like TMPFS, essentially just, put the file into memory without having to change anything?
So that's what I did locally to test this. But in Lambda, you don't, I don't believe anyway, you have any way of creating or using TempFS. But the other problem with using TempFS with such a tight constraint is that you have to be absolutely sure that you leave enough for the runtime. So you've got to divide it perfectly, which, Lambda gives you 3008 megabytes. and during testing, this executable is using 2995 megabytes. So it's really tight. So yeah.
Yeah. Is it in JavaScript or in Go?
This is now in Rust. So
have you tried to compile it against 32-bit ABI? It will be twice as small.
Look, you can compile Filecoin on 64-bit.
So, and this is the other dilemma though, which is the further we move away from the Rust proofs binary, the more risk we introduce in generating CompP that doesn't match. So if we go ahead doing it this way, I think I would want to randomly sample some of the outputs and generate CompP, a more traditional method, just to sanity check that we're not finding some weird edge case that we're not. That's the thing. This whole story has been a story of finding edge cases and discovering new things that we didn't understand, that nobody told us about. And I have a deep fear of that. So I think we'd want to sanity check pretty heavily that we're doing the right thing.
All right. Does anyone else have any updates or comments or agenda items? It doesn't seem so. Then I close the meeting and say goodbye and see you all next week. Goodbye.
Bye.